and Altium, thanks Julian, and Altium, which is the PCB design software we use for ALEASAT. And then I'll talk a little bit about the ALEASAT OBC specifically, and then I'll walk through the schematic in Altium to actually show you what it looks like. And then we can have some questions at the end if anyone has any. So to kick it off, let's talk a little bit about PCB design. So PCB design, in very brief terms, has kind of two major aspects to it. There's schematic capture and layout. So schematic capture is where you define all of the electrical connections between components that are on your PCB. So there's an example, a bit of a schematic here on the right. So this is a buck converter component. So it converts the input voltage, which is I think 3.3 volts, down to 1.2 volts. And then it needs some resistors, inductors, and capacitors attached to its pins. So you define all those connections in your schematic. And you define like component values and all of that. And then the other aspect is layout. So this is where you actually decide where the components are going to sit on your PCB. And you route traces between the pins of the components and other pins. You can also put large planes of copper for power and ground and shielding. And so this is what defines how the board's actually going to be manufactured. So you can see an example here. You've got, this is that buck converter component with its 5 pins, and it's connected to some resistors and capacitors. And this is the big inductor right here. So that's what PCB design looks like from a very high level point of view. Altium Designer is what we use for PCB design on ALEASAT. It's an industry standard professional grade piece of software that we're lucky enough to have access to for free as students. So it's a super useful skill to be able to use Altium. That being said, this is the firmware bootcamp, so we're going to be only talking about kind of how Altium will be useful while you're writing firmware. The structure of an Altium project is there's the project file, which is this proj PCB file. So this is kind of like the main file for the project, and you can open this in Altium to view the whole project. Then there's schematic files. And so a project can have one schematic file, it can have multiple schematic files, and you can have what's called a hierarchical design, where you've got a top level schematic and then sub-schematics inside of that. And that's what we have for ALEASAT, so I can show you what that looks like. And then the PCB doc file is the actual layout. Generally, there's just one of these for the project because you just have one physical board. If you had multiple physical boards, you could have multiple PCB doc files, or you could have different variants. But yeah, for firmware developers, for the most part, will be interested in these schematic files because if you ever need to figure out which pin of my microcontroller is connected to which piece of hardware, you can go check the schematic and it'll tell you for sure. So this is an example of what Altium looks like. This is actually looking at the layout file, not the schematic file, just because the layout file looks a lot cooler. So this is our actual ALEASAT OBC. So looking a little more closely at the ALEASAT OBC, I'm sure some of you have seen this diagram before. I think I showed it at the CDH onboarding presentation. But this is here again, mostly for reference, but it illustrates kind of the structure of this PCB. So there's a microcontroller in the middle, and then we've got an assortment of different components on the board that are connected to the microcontroller. So there's like the real-time clock, the flash memory, temperature sensors, GPIO multiplexer. So there's lots of different components attached to various different pins on the microcontroller. So this is kind of at a block level. And then if you actually need to go look at exactly which pins are connected, you'll go look at the schematic. And then this is what the ALEASAT OBC actually looks like. This is the second revision, which we haven't actually manufactured yet. So this might change a little bit between now and when we manufacture it, but probably not too much. So this is the microcontroller. So for firmware developers, you will be learning lots about this microcontroller. It's a TMS 570. The specific model is the LS0714. And then this is the a Pc104 header. So Pc104 is a standard for an interconnect between PCBs. So the Pc104 standard says there's going to be 52 pins here, and they've got this spacing and this alignment relative to the holes. So it defines the geometry of the interconnect. And then it can also define the signals on the interconnect, but we're actually not necessarily following that. This board plugs into our electronic power system module, and so we're just matching how they have defined their signals. So on this interconnect, you can get your the power comes in through here. In the actual satellite, when you're debugging, you can get power through the micro USB connector. And then there's also a couple other signals on this, but I won't get into the details there. There's some reset buttons, and then these here are some jumpers that you will definitely want to use once we have these boards. They disable the watchdogs, and I'll get into a little bit more about what that is later if you haven't worked with watchdogs before. And so that was the top side of the board. On the bottom, we've just got lots of connectors. So there's a connector to the comms board, there's connectors to the solar panels, a connector to the reaction wheel, and then the camera. This is the test header. So when you're trying to upload code to this board or debug it, you'll be connecting to this test header. And then this is just the Pc104 header from the other side. So I think I will pause there for a second. Are there any questions about these first couple slides and what the ALEASAT OBC consists of? Oh, I see Mitchell's got a question. What's the difference between this micro and the one on the Hercules Dev Kit? There aren't a lot of differences. This one has, off the top of my head, I think it has more flash storage and possibly more RAM as well. It's mostly kind of minor, subtle things that don't affect our development too much. But yeah, I'd have to go check the data sheets again to remember what the exact differences are. Okay, great. Are there any other questions on these couple slides? Okay, we'll keep going then. So I want to do a quick little walkthrough of the schematic. So what that's going to look like is, can everyone see my Altium window now? I just want to make sure I'm sharing the right thing. Yep. Okay, cool. So this is the ALEASAT OBC. This is the layout view, but we're not actually going to look at that too much. So the schematic starts here. So this is the top level schematic in a hierarchical schematic. And so each of these green things is a sub-schematic. So if you're interested or you're trying to figure out how some particular piece of the hardware is connected, you can go look at one of these sub-schematics. So the one that you'll probably look at the most as a firmware developer on CDH is the TMS 570 sub-schematic. So that's this one in the middle here. That's pretty much connected to everything because it's the microcontroller. So if we look at this one, it's got its own set of sub-schematics. So we've got a couple levels of hierarchy here. And so, for example, the power sub-schematic, has all the power pin connections. So this is showing, so all of these pins on the microcontroller are just for power, for the 1.2 volts and then power for the 3.3 volts. There's a couple LEDs that indicate if the power is connected. And this is an E-fuse. So this is just a way to turn power on and off to the microcontroller. So these are the kind of things you'll see in these schematic files. The one you will probably look at the most out of all of these files is this TMS 570 interfaces one. So this has all of the digital signal connections for the TMS 570. So you can go figure out which, okay, so the comms SPI connection is connected to these pins here. And then the debug UART connection is connected to these pins. So all of that is contained in this schematic file. And we have a PDF export of this as well, so you don't necessarily need to look at this in Altium. You can always look at the PDF, although I think the PDF is actually a little broken right now, but we'll get on fixing that soon. Yeah, and then there's other schematic files here for kind of all the other components on the board, the real-time clock, the flash, the temperature sensor. The other one you might pay close attention to is the backplane. So this one this is the Pc104 header. And so you can see there's power coming in on it, 3.3 volts, 5 volts. And then there's an I2C connection that lets the TMS 570 talk to the EPS. So that's all through the Pc104 header. And then also here is the USB to the USB connector. So this is that micro USB connector that was down here. And so that is another way to power the board. And there's also a debug serial connection there. And then the test header is the other one you'll probably take a look at some point. And so this is, these signals are how we program and flash code and debug the OBC board. These are JTAG signals. I'll talk a little bit more about JTAG in the next section, but it's essentially just a standard that defines a way to program and flash microcontrollers. And so we have those signals exposed on this test header, which is this header right here on the board. If you are looking at the schematic in Altium, the one other thing I will mention to you is you can use a feature called cross-probing, which lets you, if you're trying to figure out where a component is on the board, you can right-click on a component, or you can click cross-probe and then click on it, and then it zooms in on the layout to where that component is. So if you're ever trying to track down a specific component, you can do that to find where it is on the board. This will obviously only work if you actually have Altium open. But for everything else, just figuring out where pins are, you can just look at the schematic PDF, which we will fix soon. Okay, are there any other, oh, here we go. Does this work on the view only Altium? So cross-probing, I believe, does work on the Altium viewer. So there's an online Altium viewer. So if you just Google Altium viewer, this is free. You don't need to install anything on your computer. You can just upload the PCB project. And I haven't actually used this, but I'm pretty sure I saw that cross-probing does work there. So you can do the same thing where you click on a schematic thing and it'll show you where it exists on the board. If you want to use this, you'll have to grab or even if you want to use Altium itself, you have to grab the PCB files. So those files live in our GitLab. I can share out a link afterwards to exactly where they are, but it's in the command and data handling folder in OBC hardware 1. And we just learned about branches. So there's this dev 001 branch. That's the first version of the hardware. So that's the one we actually have manufactured right now. And then dev 002 is the upcoming version of the hardware, which we're going to ship out for manufacturing shortly. So you can download the files from here and then upload them to the Altium viewer if you need to take a look without installing Altium. Altium is a pretty heavy program. Like I think it consumes something like almost 10 gigs of space. So you may not want to install it if you're not going to be using it very frequently. Okay. Thanks, Julian, for that question. Are there any other questions on the topic of looking at the schematics or anything about Altium? Okay, I think I'll continue on then. Actually, there's not much left for this section. So, yes, good note, Julian. So if you want to get Altium, yeah, you can send me a message, or Julian, you can get people Altium, right? Or is it just me?
I think I can too.
Okay, yeah. In general, everyone should be able to get a student license for Altium just on their own. And that's totally free. You just have to renew it every 6 months. If you're going to be doing a lot of hardware work for the team. For UBC, we can get you a more permanent Altium license. I'm not sure about SFU. We'd have to talk to Kevin or Megan. Okay, and then here I just jotted down a couple notes about what each schematic file contains. This is just for your future reference, because I know I spend a lot of time often flipping through these trying to find the one that has the part I'm looking for. So this might help you find it more quickly. I didn't cover all of them, just some of the more relevant ones for firmware. Okay, are there any other questions about the ALEASAT hardware? So it's a pretty quick session. So after this, I'm going to do a session on microcontrollers. So there we're going to jump into a lot more of the details that are relevant to you as a firmware developer. But yeah, any questions about this? Okay.